Okay, so second part is learning to graph polar equations using symmetry. So here's number 5, 3 plus 2 cosine theta. So you have to figure out what its symmetry is. They want you to do that first. Now, here's the deal. You don't have to check everything, or you can get kind of good at it. You can say, this is a cosine, and if you look back, usually cosines, if they're symmetric, could be symmetric to the polar axis. So the first thing we're going to try, we'll try the first one, and is it symmetric to theta equals pi over 2? So here's me testing negative r, negative theta, and I get negative 3 minus, so that's a no for the first test. And then I test r pi minus theta, and that's the part B of the first one, and that's a no also. So you can work that out on your own. So it's not symmetric to theta equals pi over 2, so that doesn't help me. So I go on, is it symmetric to the polar axis? Which, hint, hint, cosine a lot of times is. You change, and that's because, remember, in a cosine, if you change the negative angle, it just becomes the positive angle. So as long as there's not other stuff to check, you're usually good. Not as long as there's not other terms and things. So we get r equals 3 plus 2 cosine negative theta, and that is equal to 3 plus 2 cosine theta. So this is a yes. So that means it's symmetric to the polar axis. So that's symmetric to this axis, okay? Which means that all I have to do is get my points from here to here. So I'm going to go for the XY chart, or it's not an XY chart, it's a theta R chart, and I'm going to pull these thetas, and then whatever point is here on these sides, I'm going to be able to put on the other side. Okay, so let's start doing that now. You have to do a theta R chart. So here we go. I am going to I first put 0, and when you put it in 3 plus 2 cosine 0 is 1, so you get 5. So you have a point right here at 0, 5. All right, now it's symmetric, so that's the symmetry line, so you can't put any other points. That's the first point. Going to the next one, I do pi over 6, and I use my calculator, and you're going to have to do that for these to accurately graph them. I got about 4.7. So at pi over 6, there's my 4.7 point. But now, because it's symmetric, this is the trick. I can go across here to the exact one on this side and put the point there. So I have a point there and there now. Going on to pi over 3, I have 4. So that's nice. It happened right at 4. So pi over 3 is 4. And going straight across to the 5 pi over 3, I get a 4 there too. All right? And then pi over 2, I have 3. So there is 3 right here and 3 right here. Let's see. Okay, so I got those. Now, so that only gets me, from here to here. And I have to figure out what's going on the rest of the way. And so I graphed 2 pi over 3, and I got 2. So 2 pi over 3, I got 2. And that means this one would be, its symmetry with this one, 4 pi over 3. And then 5 pi over 6, I got 1.23, and so you can see there, got 1.23 right there and right there. And then I put in pi. If you put in pi, you get, let's see, I'll do it down here because I can't see where I did it. R equals 3 plus 2 times negative 1, so you get 1. So we have a 1 there. So it kind of comes down and goes like that. So it's not really straight, but it sort of is on this side. So that's what our graph looks like. Okay, so that was the first graph. Let's go to the next one. Number 6. oops, not number 7, number 6, yeah. Okay, we have 1 plus 3 sine theta. Okay, let's try to figure out symmetry. So I know that if I just change r and sine theta, I'm not going to get the same thing. So we're going to try, I can try it, but you can see, here's me doing it. Negative r and negative sine theta brings that to a minus. So I get r equals negative 1 plus 3 sine theta. So that's a no. But part B says r equals pi minus theta. R is r, and the angle is pi minus theta. So sticking that into the equation 1 plus 3 and then splitting it up into the identity, cosine pi cosine theta minus cosine pi sine theta, I get 1 plus 3, this becomes a 0, this becomes into minus, and then cosine pi is negative 1, and sine pi is sine pi. So that would be r equals 1 plus 3 sine theta, which is true, which is so. We are symmetric to theta equals pi over 2. So, well, I did this in red, so I'm going to change to yellow. There's my line of symmetry. Okay, theta equals pi over 2. So that means that I can just do the points from negative pi over 2 to pi over 2. So these are the points that I'm going to use on my chart. Okay, not the points, they're the angles I'm going to use on my chart. Okay, so here we go. Let's change to maybe blue so you can see it, or green. Putting in 0, I got 1, so there's 1. Putting in pi over 6, I got 2.5, so there's the 2.5 point. And now on the other side of pi over 6 would be 5 pi over 6, so I can plot that point at the same exact time using symmetry. See how this shortens everything? Pi over 3 is about 3.6, so there's my 3.6 point, and symmetry would make that one on this side 3.6, and then pi over 2 is 4, so there's my 4. So, oops, I forgot to do this guy. 1 and negative 1 at 0. Okay, so now I'm not done though. You can't just go, okay, it's just one circle. You have to actually, I've only done the points from here to here. So now I have to go backwards from here to here. And I'm going to use the negative. It wouldn't matter whether you use negative pi over 6 or 11 pi over 6. I just use the negatives because that's usually how it's done. So if you're doing your calculator, it's easy. So negative pi over 6 would give you negative 1/2. So check it out. If it's negative pi over 6, that means I'm going right here on this angle. So I'm going to, this angle right here. And I have to go backwards 1/2. So it's this little point right here. Okay? Right here, that point. Okay, so can you see it, I hope? I'm going to put it back in just a sec. Get these arrows out of here. Okay, so that first point was right here because I had to back up and go backwards from this angle. Okay, but that also means there's one on the other side at pi over 6 there too. So I'm going to do a dot there. And then at negative pi over 3, I get negative 1.6. So here's negative pi over 3, so going backwards, there's my point right there, negative 1.6, and I have one on this side too. And then I go 3 pi over 2, and I get negative 2. So there's my negative 2 right there. And of course that can't be symmetric because it's on the pole. So guys, that makes this seashell within a seashell, okay? And you're going to learn the names. These all have names, these shapes. And then you have an inside one. So that's what that graph looks like. That was number 6, and I'll do number 7 on the next video.